confirm one by one. But if everyone sees, will be slower. I might as well decide whether to go left or right. After entering a more accurate tour. It's just like you want to go from area A to area B. Actually, you can fly. You can also take a car. Usually, a general route is determined first. Then step by step. In fact, relatively speaking, this will transfer data faster. So we can now let go of the perspective. Don't think of it as a community. You imagine the world. A network of all things. We have now subnet. That in the large network environment. Of the entire network. You think about it. What will data forwarding look like? It will be slower. That is. Now there are more subnets. It's true that you can save IP addresses. But brought a new problem. That is. The efficiency of forwarding will be reduced. So we're thinking. When this data is forwarded. Can I see a little less information? Can you forward it a little faster? Let's look at this picture. As a company, I will give you a brief introduction. It says LAN. It stands for Local Area Network. This is an internet. That is. Between us. To advertise some routes. Check back later. To forward the corresponding data. Let's ignore its specific address format. Why do devices and operators advertise routes to each other? These you will learn when you come to the NP stage. Let's just talk about technology for now. Stop talking about the scene. Because now, in terms of some technologies of IP addresses, now a network is divided internally. 1.0, 2.0, 3.0. We can make a division. So how exactly do you calculate this? Let me tell you briefly. As the internet, there will be a lot of users connecting with it. For example, this is your company. You have to make some announcements. With the operator. That is. Devices you want to connect with them on the internet. Make some announcements. Your company notice 4. Another company announcement 4. Suppose there are 20,000 companies in region A. That's 80,000. Although the final announcement is not a single device. But it is also a large network of operators as a whole. Too much information on the internet. As for the operator, to forward the corresponding data to you. I don't care how to get to this device. Either to 0.0, to 1.0, or to 2.0, or 3.0. Actually, go through this router. So I don't care at all whether it will reach the device precisely. As long as it is guaranteed. Now traffic can go to this exit. That's it. As for the fine division at the back, just forward it. It's like a school. In that school, this internet assumes the principal. If this is the head teacher, behind this is a student one by one. For the principal, it doesn't really need to know where the students are seated. Just need to know which class are they from. Just ask the head teacher. Then let the head teacher find the students. The principal has to deal with a lot of things every day. There is no need to record in which classroom and where in the school each student sits. The principal only needs to know which class the student is in. Find this head teacher. The head teacher can find students for the principal. That's what I mean. For operators. It is connected with a lot of users. So, each user will have information to interact with. Then finally, operators don't need to know everyone's precise information. Just make sure that the business can be normal, covering the current range. When the operator announces to the outside world, "We are nothing but hope," the operator's traffic can return to the internal network. So just make sure can interface with this export device. Traffic will be able to come down through this device in the future. We can now put multiple small subnets. Use a larger network scope to generalize. Then optimize the overall appearance. That's what I mean. So for the device, as long as future traffic can match such a route, be able to direct traffic to such an outlet device, it can perform more precise forwarding. This is what we call CIDR. So how exactly is it calculated? I can also briefly tell you. I'll tell you how. You can do the calculations by yourself after class. It is calculated in the same way as VLSM. First convert it to a binary. After turning, you will find they have a very large number of digits in front of them, all the same. This is a total of 4 groups. You do the math after class. The preceding digits are almost always the same. When you compare them, continue to compare until a certain person is different. Stop from that one. Then set all the following values to 0. Then it is calculated that this. The first step is to convert all the network to binary. Then start from the first. Compare later. Until the comparison to a certain behind is different. The previous requirements are exactly the same. Stop all from this one. Then all the following values are 0. Then the front is the network bit. Behind the host, it is the large network segment advertised. This is what we call classless interdomain routing. Sometimes it will have some other situation. I leave you with an extended knowledge. But it doesn't matter. For example, now add a network segment 10.24.4.0 24-bit mask. So you will find, when summing up 5 of them at the same time, some problems will arise. You will find that a large network segment is counted. But this network segment will cover more. For example, it will cover 5.0, 6.0 and 7.0. Sometimes advertised routes. It's not so rigorous. 22-bit mask. Just enough to cover all the changes. It just represents from 0.0 to 3.0. Such 4 network segment ranges. But if you add a network segment, such as 4.0, aggregate them together. In the aggregated network segment, there will be several other network segments. It's just a few more small network segments. What if this happens? If this is what I said, just sum up the 4 of them individually. Then put this extra. Just announce it separately. There is no need to bring them all together. Finally, to sum up, we learned about IP addresses today. Then learn the last 2 techniques, VLAM and CIDR. We learn VLSM to make the mask longer. Learning CIDR is to make the mask shorter. I'm going to subnet. I'm going to merge these subnets again. And then announce. You might think it's contradictory. First, these 2 technologies, their scenes are different. Is not conflicting. We can take a company as an example. We as a network engineer. To plan the network segment reasonably for the company. Equivalent to